Hi everyone. Just a second video, unscripted again, to try and talk a little bit more about some other debugging features that I'm planning to introduce to G.V. So just today we're gonna use a few examples, and in these examples we'll be using the Tinkerpop crew graph that is found on the official documentation. So just for reference, this is what the graph looks like. We've got a very simple structure with software and person with edges that link people and software together. So before I start showing some of the new functionality that I've been looking at introducing, I just want to quickly circle back to a concept that I've very briefly discussed in the last video around the use of breakpoints for debugging. And what essentially boils down to is that I've realized breakpoints in this case are not really necessary. We have the advantage of being able to navigate the query both directions effectively. And so instead of introducing breakpoints, I've actually just introduced the ability to directly navigate steps by clicking on them, which just makes for an overall smoother experience, I think. So just closing on that, the functionality that I want to demonstrate today actually is Traversal Simulation, as I've called it. I couldn't really come up with a better name, but the sort of core idea is to try and explain to the user how a given traversed element, a given stage in your query maps to its final output. So I'll put some visuals to this in a second, but essentially what we're looking at is how this little vertex right here eventually turn into a given element map, and does it actually turn into this element map? So if we take our query here, it's quite simple. We're just filtering vertices of type software, and we produce the element map. So if we pop that through the traversal simulation, this is what we get. So the view is actually really simple. On the left-hand side, we have all the elements traversed at this stage of the query. And on the right-hand side, we get a little report of the output correlated to that traversed element. If there is an output, so in our example, vertices of type person won't result in an element map simply because they're going to be filtered out at this stage right here. So if I look at it, we'll just be able to see the vertex details and that there's nothing under it. But if I look at the software, we'll essentially get the resulting element map produced underneath. If I move my query up to this stage, we're going to be, again, looking at this same simulation, but at this point in the query, essentially just allowing to view how the results evolve as each step of the query is taken and how they correlate back to the final result of the query. So just a really simple example there to start. I'm going to move on to a slightly more complex example, albeit not a very complex one still. So in this query, we're essentially just looking at the vertex on the other side of any edge coming in and out of our vertices with any one of these labels. So if we look at this here, this is the result we'll get. And now where it gets interesting, and I need to fix the scrolling for this, is that you'll have the ability to actually view the details of these objects directly in there. And once again, you get the ability to view for each of these vertices what the exact output of that is. So for instance, if we take V1 person and we refer back to our view, so we should be looking at 2, 4, and 3. So if we go and look at our V1, which I need to remind myself which one they are, there we go. We should be seeing 1, 2, and 3 right here. Those are the 3 vertices that lie on the other side of the vertex that comes in or out of this. So we're going to have 2, 4, and 3 right there. So just to showcase that it does in fact do what it's claiming to do. And just for our last example, we're going to take a slightly more complex query again. So this one is actually very well explained in the documentation, and I don't think I'll be able to explain it as well. But essentially, it looks for vertices that, or rather, in this case, people who have collaborated, I believe, by creating a software with someone that is of age 29 on a software that has the name LP. And so what we get at the end of this is this final result here. We can see that some people do not fit this criteria. Software, of course, not fitting this criteria because there is no outgoing vertex for software of label created, but we can see which people have got this working and what the actual output is. So in this case, A would refer to the actual user, so in this case Josh, and C would refer to the person that they've worked with of age 29, in this case Marco. So again, just another example to demonstrate all this. So the functionality itself is still at a really early stage. It doesn't work for all queries. There's going to be more complex cases that are going to be evaluated. One in particular, for instance, being how do you make this work when you evaluate inside of a traversal. But sort of the next few weeks are going to be focused on fleshing this one out, improving the visual as well, and also eventually allowing for this traversal simulation not to be just run between the selected step and the final one, but between any two selected steps. So for instance, we could imagine a traversal simulation being produced between these two steps, which would essentially output the same as this one, albeit with a slightly different output shown. If we were to compare these two steps, we'd be showing vertices as the output of themselves, whether they've been matched or not. And here we'll be showing the element map, which is just some further indication as to what's in the pipeline for this. So yeah, that's everything for today. I'll probably be a few weeks till the next one, just while I work on all this. But if you've got any questions, comments, you can find me on Twitter, Discord, etc., etc. And yeah, hope you enjoyed.